Okay, a little bit of window management here. All right. So hi everybody. Welcome to my talk, Trials, Traits, and Tribulations. Here we are. Okay. Hi, I'm Stefan. This is my Mastodon handle. I also am on X Twitter. And this talk, I have given it originally at Eurorust last year, and I was eager to present it again because I really love the story that we did here, because it's a story about the time when we at Dynatrace, the company I work for, when we adopted Rust. And yay, we adopted Rust. So that's the first thing. That's fantastic. And this is what we did actually. So it's one of those things that, we wouldn't have been able to do without Rust. We created our own JavaScript runtime. Pretty amazing, huh? So it builds up on V8, thanks to the Deno team for providing fantastic Rust V8 bindings. We make very much use of that. And the idea is that you have two modes of executing JavaScript. One mode is the application mode. You have an application on disk, you load those files, and then you execute them in a worker. And the other one is having ad hoc codes that come in from an event source. So you say, oh, user X wants to execute this particular piece of JavaScript right on the worker, and it comes from somewhere, and we don't know what it is, etc., etc. So there are two modes. They are slightly different. And this was our first idea when we adopted Rust. And this project was pretty popular within the company, and we got contributors from other teams as well who wanted to try out this new language. And then, we got contributions like this, for example. Somebody was trying to load some files from the disk. They wrote a function called get directories recursively with root of type pathpath. They weren't sure if they really wanted to do that, so they did, of course, a code comment. They said, okay, this function gets directories recursively from a root directory. And actually, while they were developing, they found out, well, actually, they are using a non-recursive approach. With the comment, the function name might be misleading. So close. But anyhow, this is very honest, actually. The example that I just showed you shows that code is evolving. Often we start out with a totally different idea that we end up with, and further down the road, change will be inevitable. So especially if you're new to a new programming language like Rust, a programming language that doesn't allow you to cut corners and is therefore often seen as hard, you will most likely spend more time fighting the borrow checker or working with wrapper types than thinking about good software design. And this is the content of my talk today. I want to go with you through a piece of code that ended up very varying, very hard to maintain, and give us real headaches, and which we refactored over the course of time into something that allows us to write features faster, that is easier to read, easier for our colleagues from us to be onboarded, and easier to contribute. Big disclaimer up front, everything that I show you is fictional, but rooted in reality. So I took a couple of code examples, I massaged them into something that hides all the details that I'm not allowed to talk about. But what you see here is something that, mimics the real world. So if you think about a couple of semantic decisions that, hey, they don't make quite sense to you, yeah, it's most likely lost in the translation of, removing all those details. And this is the culprit. This is the function at large. And you might say, come on, Stefan, what's your problem? This fits on a slide. Well, actually it doesn't. So there are a couple of lines down there, which I cut off. And at the lowest font setting, and I removed about 200 lines of monitoring code as well. But still, this function is called event handler. You're not going to see that. You're going to see that later. And it connects the event source to the worker, where we decide which strategy to use, if it's an ad hoc app, if it's an ad hoc function or an application function. And it has a couple of tasks that we are going to figure out together. The very first question that you might ask, and this is a very important question, is, do we need to change anything? If this code is never touched again, then just keep it like that because it works. Why bother? Let's just forget it, never look at it, use the VS Code collapse feature, put a nice little blanket on top of it, and ignore it for the rest of the time. But once we do need to change something there, things might get hard. And a couple of things show up. Like first, this is outright overwhelming. I wouldn't know where to start. I can't keep a mental map of this code in my head. I can't keep a mental map of my code in my head, let alone the code of an entire team. There's lots of indentation. It's very hard to navigate. We have unclear responsibilities. What does what? Why are things like that? It's very hard to see. And there are lots of similarities which, make it even harder to figure out what's going on. It's hard to keep in mind what's happening. And this is why we need to refactor that. So if you wouldn't have touched it, if you wouldn't need to maintain this piece of code, then just leave it like that. But otherwise, this is your work. The first thing that I always do, this is the first trick, I collapse. So I just go to the first indentation and I collapse everything so I get stuff on the screen and I can see what's actually going on. I try to understand what's happening on the first level. And there are a couple of things that we see. For example, we create a new configuration. Okay, that's good to know that we need some sort of configuration. Even though we don't need the details, we at least know that a config is needed. And then we see, once we handle the requests, we check for the application mode, okay, and then we go into this else if else construct, where we say, okay, the other mode should be ad hoc, but we are not checking for ad hoc. We are checking if a condition for ad hoc is met. And then we have a general else branch that, if everything goes wrong, stuff will most likely happen in there. So, okay, we get some overview. We know a little bit more about our code. So that's nice. Also, if we look at the function signature, we see that we are returning a result, a handler result. This is our return type. This is what we expect. But we are also able to return any error. This is a boxed error of a trade object that is thread safe. So we also know that if there is an error, we can just return it because we don't care which error it is. It can be any error. Good. Stuff that we found out by just collapsing our first level and get some overview of this monstrous 1000 line of code function. Next, we open up the first if statement or the first if branch. And in there, we see another if branch. Apparently, we check if we get an URL from the event source, which listens to the name health. Very funny name. Then we do some extra checks. So in our application, we load those files from the application mode and see if they can be parsed. So we have an evaluation going on. It says it even here in worker evaluate, where we evaluate the code if it compiles, if it can be run. Otherwise, we wouldn't run it. Otherwise, we say, okay, let's return some error. And there are a couple of very interesting things in there. First of all, one thing that I didn't understand was that we check if the evaluation causes an error, then we unwrap it, and then we wrap it again, and then we return it. So we get an error, we unwrap it, we wrap it again, and there's a simple solution for that, which is error propagation. So instead of doing that, instead of looking into the error, just add the question mark operator. If there's an error, just bubble it up. Otherwise, continue with the result that you get. This is what I like to call happy path programming, because you just take care about the stuff when everything goes right, when everything is okay. And if stuff breaks, just bubble it up. Fantastic. The next one that you see is that sometimes we just return a okay message. This happens at several points, but also here at the health check. This is the first occurrence that we see. And this has been highly debated at Eurorust, but we, in the domain that we worked in, we can think of that as a default response, like something that we want to return in case there is no deviation from the default, from what we expect. And if we think about it as a default response, we can implement the default trait. So the first trait that we implement for our handler result is, well, default, where we do just the same thing. And we replace those 3 lines of code with the new line where we say, okay, let's create a default handler result. And it's just 3 lines, but this is not about avoiding redundancy or about abstracting something away. You could use a function or just set defaults for the optional fields or whatever. This here is to communicate intent. The default trait says that this was meant as a default. I know what I consider as default. My team members know what we consider as default. And even Rust can instantiate the default response if a handler result needs to come up somewhere in a different struct. And this is what abstraction is actually all about. It's not only to reduce code and avoid redundancy, but also to provide semantics and context. We hide the unnecessary parts and provide the important parts. a status code of OK as U16. That's an implementation detail. That this is a default response. That's something that we as a team can do much, much more with it. Alrighty. Not done with the function. There's still this part where we load code from a path and then get the file name. And the file name is interesting because V8 needs a file name to work with. Even if they don't mean anything, you can write anything in there. But for every execution or evaluation, you need to provide some file name. And there are several types involved. We start with a path buff. Then the file name function gives us an OS string, which we map to a string. And this can error. This is an operation that can fail. So we call unwrap, and then we call toString to get an onStruct. The first thing that comes into mind is the unwrap function. It should be safe. Haha, famous last word. But hey, at least provide a fallback. Something like no file name found. And we could leave it like that. It's a bit safer than before. But actually, this piece of code comes up again and again and again in our code base. In the health check, in the actual execution, even in the ad hoc mode, where we set it to just any random string. So this is also a process where we have certain semantics in mind. And by repeating it over and over again, we risk that we differentiate between implementations at some point. Or we just forget some very important detail. And what I like to do here is I'd like to introduce my own abstraction, my own type, a new struct that is a wrapper type for file names. I like to use tuple structs here with one field, because what we do here is we take a primitive data type that already exists and lay our own semantics over it. We separate the knowledge of what it is, not only in the variable name, but also in the type. To get from a path buff to a file name, we use a conversion trait called from. Again, this is the same code as before, and we could easily just use a parsing function somewhere. But again, this is about communicating intent. And this reads like English, from path buff to file name. Fantastic. It tells us a story. It tells us what to expect. And back from file name to string. Simple conversions that tells us what it is and what it's compatible with. We can focus on the task of converting without needing to look at the actual conversion. And then we create another default for the ad hoc case where we say, well, it's just script.js. Whoever, I don't need to have an actual file name. It's just the code. So for the ad hoc case, we use this. All right. And with that, we can reduce this part to, just a couple of lines. Our health check now is super small, 5 lines where every line tells us exactly what happens. And if we take the file name type in the rest of our code as well, we can even save 1 or 2 conversions for later. And, also those changes have some effect on some code in other parts, because we can reuse the handler result default, we can reuse the file name. This is code that is getting repeated throughout our program. So what did we do? First, we introduced defaults. We made good use of error boundaries, fantastic, and we introduced our own type. But there's more. We learned about the event handlers interface. We got some information on which types are necessary, what the domain is about. We work with files and codes. We return something that looks like an HTTP response. And more importantly, we understand now that stuff can get wrong, and then it's okay that we return errors. Okay, to the next example. This is something that comes in the configuration section a lot. We look at a headers hash map and check if there's some particular key in there. And if it's there, we get it, we map it to something that we can own, and then we unwrap it. Some of those keys are optional, and other keys are required. And there's also a lot of domain knowledge necessary to understand what's going on there. And I especially like that we check if something is there, and then we get it and unwrap it. I don't think this is how you're supposed to use the result type. And this operation comes up a couple of times, 5 or 6 times in our code. So why don't we introduce another type that abstracts this? Since this operation can result, the first thing that I do is create my own error, because it's an header error that could happen. To create an header error, I just create an empty struct. I'm not cared about any contents. I'm just care about the error itself, and the need to implement the error trait, the debug trait, and the display trait. Now I have an error that I can use with a boxed error, with whatever. And then I create another struct, a header struct that wraps the hash map And then I implement two methods, one to get a required header and one to get an optional header. And I think this is beautiful because the method signature tells us everything we need to know. Required headers can cause errors if not present, and optional headers, well, they can be absent. That's what an option tells us. And just as with file name, we added our own semantics on top of a standard data type. The characteristics of the data structure move to the back, and our goals of what we want to achieve, that comes forward. Again, abstraction is here to hide the unnecessary parts and provide information on the necessary parts. But I think headers is a little different. Where file name is a type that serves as intermediate carrier between a source and its ultimate destination, we invented headers just to add some more methods to make extracting a header information more convenient. And we should wish our original data structure actually would have something like this feature, characteristic, or dare I say, trait. And this is what I do now. Instead of a struct header, I introduce a trait header. It tells us, again, everything that we need to know. It tells us everything that we care about. And instead of implementing the header struct, I implement headers for the hash map of string and string. It implements the right methods, it implements the right results, and we know about the right errors. If we ever decide to change the underlying implementation, our event handler code doesn't change at all. It's just a concern for some other part of our program where we decided that we want to have a hash map and not for the way we get our information. Why should we care that our headers are a hash map after all? We're just here to talk about those headers. And this is how we use it. I get the required headers, optional headers. The question mark tells me that there can be an error, so I bubble it up. And I know from the method signature what's going on. And I reduce my code effectively. Okay, a couple of little changes in the config part and in the app mode part, but now for the main act, and this is going to be something. Breathe, 1, 2, here it is. This is the application mode part, and again, I hope you can see it. If not, let's wait a little bit. We make it better. It must be very readable for you. But the contents are actually not that relevant. What we see is that we can apply some of our learnings already. First of all, here I have again a file name that I create somewhere. So I have a struct for that, bam, reduce it, and just call function path.into. Done. Here on the next line, I check if something is some, if the option is there, and then I create some, otherwise I create none. So this is like doing the same thing, which is actually here. There's an option API to convert one option into another option. This is what I'm using here, so it gets smaller again. And now that I reduce those lines, something new comes into the view. A default handler result. Look at that. It's the same handler result that we had before. And you know what to do there? Call handler result.default, and it gets smaller again. And now we are at this point, which is very interesting. I have two method calls. One here is to map the execution of my worker to a result. And the other one is something where I just return an error, error.into. If it's an error, just return it. And since we already introduced proper error handling with error propagation, we can get rid of all the mapping functions and use error propagation. And now look at that. Now everything from the worker part with the application mode fits on a slide. It's still a lot, but it fits on a slide. And now I take this part on the left side and put the ad hoc mode on the right side. And they look a little bit different, but we can already see some very similar structures. App mode has a clear distinction between a runtime error and the result. In ad hoc, I can have both errors and results, which is weird at first, but then again, I'm having a JavaScript runtime. Hey, so this can happen. But that's it for reduction right now. Let's look into other similarities. In all cases, we need some code. We need to get the code that we want to execute. We need to get a file name, a file name so the V8 runtime knows what to do. We have some payload that we have, some payload to invoke our function with, so it can work with. And in the end, we execute it and create the result for that. So those are the similarities that we have here. We need to get to those parts from somewhere. And we have the same preconditions, even the same properties, but how they are executed, they differ slightly. And this is something that reminds me of something that I learned 20 years ago at university, which is the strategy pattern. And I don't know if you heard about this traditional design pattern. I forgot it, by the way, so I was so annoyed by everything Java and enterprise that I annoyed all the learnings that we had 20 years ago. But then I found out, in that regard, actually it makes kind of sense again. What I have here is I have an executor that doesn't know about the actual implementation of the strategy, but can plug in one of two different strategies to work with. Either it's the ad hoc strategy or the application strategy, and it just takes the right properties over an interface that is, there for both implementations. This is the trait for the strategy, where we can find the same for things that we saw in the execution of the app and the ad hoc mode. We find the file name, we find the code, the payload, and parsing a result. And look at those method signatures. It's so clear what to expect. File names gives a file name, a struct file name. Code gives us probably a string or 8 errors if the error, the code is not there or for whatever reason. Payload is a 30 value. And both health check and parse result can give us a handler result, so we can return from it, or we're getting an error. It becomes very obvious what every part is about. Those are the things that we need to provide for our strategy. All right. And then we implement the strategy for ad hoc. So first, I create a new ad hoc strategy. I say what the task is, don't worry, that contains just some information, and I want to come from the event that's coming in to the strategy through a conversion function. Again, it tells me I want to come from that to that. Now I have a strategy, now I can work with it. And then I implement the event strategy for ad hoc. And look at that, it's not important what every line does, but you see, once we removed, or once we found out all the parts that we actually care about, every line that we implement becomes almost just a single line of code. And maybe, the handler result that we do down there, it's just setting properties based on what we get from the worker result. So it becomes clear what it does. And every method here tells a story. It's easy to maintain, and we know what's happening. And we see our old file name type again. Look at that, how beautiful. Then we execute it. This is the executor. It takes one strategy. I've chosen to use a trait object just because it was the closest thing to do. And then we have all the 3 steps from the original function. So first of all, we are getting the file name. Then we are getting the code. Then we are getting the payload. We feed our worker with it. And then once we have executed it, we parse the result and return a handler result. This is the execution function. And this goes for every strategy. So I could show you the implementation for the application strategy as well. It's a little bit bigger, but those are the same implementations. And this is everything that we need. Again, we focus on the process, maybe very much like the original code started out to be, but then we put away the details to some other place. Okay, so what's this? Do you recognize it? This is how our event handler function looks now. First of all, we have some reduced configuration. It's not 100 lines of code anymore. Not at all. It tells us exactly what we are getting. And then we think about a strategy. We think about a strategy, and based on the enum, we are creating a new strategy. Either it's an app strategy or it's an ad hoc strategy. It's suddenly we are not in this weird if else construct anymore. Not at all. We now have a strategy that we can work with. And last but not least, we execute with our strategy the process from the executor. We pass it here as a parameter with the config and with the worker. Then again, based on the path, either itself, we call the evaluate call and return early without executing anything, or we execute it and actually execute JavaScript. So it becomes much, much clearer what's happening here right now. And we have 3 very distinct blocks that are separate from each other, where you can find in every line of code what's going on. Beautiful. So this is actually one thing that we can now maintain and work with and extend to our needs. So we have to ask ourselves the question, hey, was it worth it? So yeah, so first of all, we got rid of all potential panics. We have proper error propagation. We know when we propagate an error and we know which error we propagate. Fantastic. Also, we can change things where they belong. We have now much, much faster iterations because we're just taking one particular method and change something there, or add a new method if we want to introduce a new feature. And yeah, so we don't need to parse this humongous function again to see where we need to change all the details to make all those modes work. We can do it within those modes very clearly. And I don't know if you can hear my kid scream, but I can. And we can test our features in isolation. We can even have a mock strategy so that we know what's going on there. If you just want to test the executor flow, or we can test the strategies in isolation. And contributions are easier as our code communicates clearly what's going on. Still, there's a lot to do in my opinion. Is it better? I don't know. Is it the best solution? No, sorry. Is it better? Definitely. Is it the best solution? I don't know. My colleagues came up with something entirely different, but equally helpful. So it's again, a good solution if you just try to refactor it. But we have a lot of things to do. We can maybe select a strategy earlier. We need to ask ourselves if we need to work with thread objects. Do they have a downside for our case, or are they okay for our case? This is something that we need to figure out. What about all the reference counters that are introduced? Can we have clearer structs that maybe work with references? Why do we need to share them? And are we okay actually with cloning a few elements just to, comply with ownership, or should we do something better there? I don't know. But this is something that we can now figure out much, much better since we can look at our code and see what's going on. If you have 3 learnings from that talk, first of all, use proper error handling, write for the happy path, use error propagation. It makes your code so much more readable. Introduce your own errors if you want to have some errors. And interfaces that return a result speak a lot to you. They tell you a story, they tell you what's going on there. I implemented default and conversion traits, but in general, implement traits from the standard library to communicate intent, communicate what's going on, especially going from a path to a file name. There's a process behind it, but you don't need to care about the process. The only thing that you want to care about is that you go from a path to a file name. And this is something that we communicate by implementing standard library traits. And if you want to abstract for semantics on types that already exist, use your custom traits and types. We introduced the header type, which is beautiful because we can remove the underlying implementation for something entirely different, but everything stays still the same. We introduced the file name type, which tells a different story than just a string. What's clearer, a string called name file name, or actually the type file name? And you can have multiple file names with different names. We introduced the event strategy trait, which also tells a lot about what to expect. And we can hide all those implementation details. And those are the 3 steps for refactoring that make your code base a little bit better. And I want to thank you a lot for your attention.